Hi guys, a very warm welcome. And in this video, we are going to talk about some of the additional AWS services, primarily related to automation, related to file storages. So many things we are going to cover up in this particular session. So what are the objectives? After covering up this session, you should be able to understand and implement CloudFormation, demonstrate about Elastic Beanstalk. You will understand the working on CloudFront, understand the concept of Elastic File System, even understand the concept of Elastic Container Service, and also understand the concept of API Gateway and the Web Application Firewall. So I'll start with the CloudFormation first, and what exactly the AWS CloudFormation is all about, and why do we need AWS CloudFormation? By now, we can work on a lot of AWS services, and if we want to automate the entire IT or the services that we create on the AWS, how we can do that? So till now, we have been creating the resources manually. Let's say if I need to create an EC2 instance, so I'll just go to the EC2 dashboard and create an instance. If I need to create a bucket, I'll go to the S3 and create a bucket. If I need to create a VPC, I'll just go to the VPC section and create a VPC and its components. So everything manually I need to do it. Now when we deploy our solutions, in the solutions there are so many services that run together. And one by one, if I move or switch over to the services, it will take or consume a lot of time. So is there a procedure that we can automate the entire solution creation? And yes, that we can do it from the CloudFormation. So an application on the AWS may require a certain set of resources, and managing these resources is not an easy task, even it consumes more time. So this management part can be skipped if we make use of the AWS CloudFormation. Hence, using CloudFormation, we can manage, create and provision all these resources at same time. So if we have to create all these resources together, we just have to create a template and deploy the template. So what we need to do mostly in the CloudFormation is how to create that template and what is the template structure. So what exactly the CloudFormation is? This is a symbol representation of a CloudFormation is, and it automates and simplifies the task of repeatedly and predictably creating groups of related resources that power your applications. So you can work on the CloudFormation with the help of the AWS console also. Even you can work on the CloudFormation with the help of the command line or the CLI as well. Now what are the components of the CloudFormation are? These are the three components of the CloudFormation that we need to look into. But one of the most important component is the template creation. So first thing is we need to create a template. And generally the templates are created in the JSON format or the YAML format. And here we need to define the parameter definition, resources that we want to create, and what kind of an output that we want to achieve. Then we run that template. First we validate that template for any errors. And then we run that template on the CloudFormation stack. And then once the stack is running, we can actually view the output of our solution. So what exactly the stack is? Stack is the collection of all the AWS resources that we create or we get it created from the CloudFormation. Now how does a template in the CloudFormation looks like? As I mentioned, the template in the CloudFormation is in the JSON or the YAML format, and these are the major elements of the template structure. The first is the description. Then we need to define the parameters. Then we need to work on the resources, output, what output we want to achieve, likewise. So if you look into this particular template, this is an example of how to get an EC2 instance created by just running a template from the CloudFormation. So you look into the description. What we want to create an EC2 instance running the latest Amazon Linux AMI. And in the parameters, we define the key pairs and all those things. The major important thing is the resources. And from the resources, the CloudFormation template gets to, or the CloudFormation gets to know that what all services and the resources that needs to be created. So in the resources, here it is mentioned EC2 instance, and the EC2 instance properties, the image ID is mentioned, which is which AMI the CloudFormation should be selecting for running the instance, what type of an instance it is going to be, would that be T2.micro or M3.medium, and what would be the key pair name that will be created. Likewise, whatever resources that we want to create, we just have to specify the service and its properties. So let's say if I need to create an RDS, so I'll just mention RDS, and the properties, I'll include the database engine image, the type of an instance that I need to create, and all those other parameters. And in the output, how the output should be published. And here we want is the instance ID of the newly created EC2 instance should be reflected. So you can read through this slide and you will try to understand, you will be able to understand further how the template is created. And some of the sample templates you get it from the CloudFormation service directly. So when you see the lab video for the AWS CloudFormation, there itself there are some sample templates that you can read through. And there are a lot of open source platforms also where you can get some AWS CloudFormation samples that you can actually edit based on your requirement. Now, what exactly the stack in the CloudFormation is? Stack is the collection of AWS resources. So it is not necessary that I need to create a single stack, and in that single stack I'll get all the AWS resources created. I can have multiple stacks also in the form of a parent-child model. So the resources are created, deleted or updated in stack, and it defines by AWS CloudFormation template. A stack can be nested with another stack, and this results into the hierarchy of stacks. The top level stack is called as a root stack. So this is a root stack. All of the stacks in the hierarchy belongs to the root stacks. So about AWS Elastic Beanstalk. It is also an automotive service, but it is primarily used for deploying the applications quickly on the EC2 instances in the backend. So what the Beanstalk does, with the help of the Beanstalk, it creates the platform for the developer so that the developer can focus on building up the code, develop the application, and once the platform is ready, the developer can directly upload the code via Beanstalk. Now what the Beanstalk does is, in the backend, the Beanstalk creates one EC2 instance, and on that EC2 instance, it deploys the code automatically. So the Elastic Beanstalk is used as a platform as a service model. So Beanstalk as a PaaS for deploying and scaling web application and servers. The web application and services are developed via programming languages. So you can develop your code either using Java, .NET, Python, Ruby, Go, and many other web applications. The servers like Apache, Tomcat, Nginx are used for deployment, even PHP and all as well. So this is a symbol representation of an Elastic Beanstalk is. Why do we need Elastic Beanstalk? So as I discussed that the developers can focus more on building up their application rather than focusing on the creation of an infrastructure. So when a developer deploys an application using Elastic Beanstalk, it automates services such as load balancing, provisioning servers, auto scaling, creating environment to run versions of the applications, maintaining security, basic health checks, and the monitoring. The AWS Toolkit for Visual Studio and the AWS Toolkit for Eclipse allow you to deploy your application to the Beanstalk and manage it without leaving your development environment. Hence, developers can focus on developing their application and are set free from deployment-oriented tasks. So, what are the features of Elastic Beanstalk? Elastic Beanstalk is the fastest and simplest way to deploy your applications on AWS. It enables your focus on writing code rather than spending time on managing and configuring services. It automatically scales your application up and down based on application specific needs. It gives freedom to selected AWS resources like EC2 instance type that are optimal for your applications. Now when we work on the Elastic Beanstalk, there are certain components that we need to look into. So an application is a component of an Elastic Beanstalk, which is a collection of environments, version, and environment configuration. An application in Elastic Beanstalk is conceptually similar to a folder only. Now, in the app version, an application version refers to a specific labeled iteration of deployment code for web application. So you might be having multiple different iterations for your applications that you have developed, and you can have the app versions created on the Beanstalk for every iteration and tested accordingly. Now, what are the components of Elastic Beanstalk that we need to create when we work on the Beanstalk is the environment. Environment is the place where you actually launch your application. So there are two types of environment. One is the web environment and the other one is the worker environment. So in the web environment, you mostly deploy HTTP, HTTPS related applications, because in the web environment you get the traffic directly from the internet. So mostly websites, web applications, they are deployed. And in the worker tier, all the background processes, all the background tasks or backend applications, microservices applications, they are deployed in the worker tier. So it is up to you for which purpose you are going to create an environment, whether it is going to be a web environment or a worker environment. The other good thing about the Elastic Beanstalk is when your environment is created, it also gives you the health of the environment. And you get to know that whether the environment health is good, you get a green color. If any of the checks are failing, you get a yellow color. If everything is failing, you get a red color. And apart from that, you can also do the troubleshooting directly from the Beanstalk. So about the content delivery network or the CloudFront service, it is primarily used to deliver the content quickly to the users. It could be a possibility that the content might be available in a particular server. Let's say we put up a content in one of the locations. Let's say we take up an Ohio region, or I create a bucket in the Ohio region and I upload all the content in that bucket. Now whatever the content that is in the bucket can be accessed globally by any user. So as a service provider, as a content delivery provider, we need to ensure that the content provided to the users across the globe should be opened quickly at almost at the same latency. It should not be like anyone who is nearby Ohio region should be able to open up the content quickly. Anyone who is located at a far location may observe a latency in terms of opening up the content. So we want a uniformity. And how we can achieve that? That can be done with the help of the CloudFront service. So CloudFront is called as a content delivery network or the content delivery service. It acts like an intermediate point between the main server and the end user. The data get cached to speed up the delivery process of your static or the dynamic content, and it delivers the content through edge locations. So what are edge locations? Edge locations are kind of point of presence servers or POP servers. AWS has the point of presence servers across all the AWS regions. Also, at the locations where the AWS regions are not present, there also the POPs are available. AWS has tied up with many service providers that are offering them the point of presence or the edge servers or the edge locations. So the CloudFront delivers the content with the help of those edge locations to the users based on their location. The CloudFront reduces the number of networks that a user request must pass through, and it increases the data transfer rate as well. How do you set up CloudFront to deliver the content? You create a CloudFront distribution to tell CloudFront where you want content to be delivered from, and the details about how to track and manage content delivery. The CloudFront uses computers, edge servers that are close to your viewers to deliver that content quickly when someone wants to see it or use it. So here in the diagram you can see that for the CloudFront distribution to be created, in the backend there has to be a source where the content is available. Let's say I take up a source as S3 bucket. So the developer is going to create an S3 bucket in the point 1, and then the developer is going to upload the objects in the S3 bucket. It could be anything. It could be an image. It could be an HTML file also. Then the developer, with the help of a CloudFront, is going to create a web distribution mentioning the details about the S3 bucket. The CloudFront distribution is going to give a domain, a DNS, through which the content can be accessed, and it is going to take the object from the S3 bucket and distribute it to all the edge locations across the globe. And that's how the CloudFront distribution works. Now the content, when the user tries to access a content, instead of directly routing the user to the S3 bucket, the user would be directed to the CloudFront nearest edge location. So let's say if anyone tries to access the content from Mumbai location, they would be referred to the nearest edge location in Mumbai only. If anyone tries to access the content from Singapore location, so they would be getting the content from the nearest edge location, which is nearby the Singapore only. So likewise, and hence this content provider can provide the uniform latency to their users. So that's what we have done in the labs also. We have created a static website on the S3 bucket. We have hosted a static website on the S3 bucket and displayed it or accessed it using the CloudFront distribution. Now coming to the next part, that is another service of the AWS that is called as an EFS or the Elastic File System. The Amazon Elastic File System is a serverless fully elastic file storage. We have discussed different type of storages in the previous sessions. We have discussed about the S3, which is an object storage. We have discussed about the elastic block storage, which attaches to the EC2 instance. Likewise, there is another type of a storage that we can use on the cloud, and that is called as a file storage. It works just like a network file system in the on-prem environment. Now, why do we require a file system? For example, let's say if we talk about an elastic block storage. So elastic block storage volumes can be attached to an EC2 instance, to a single EC2 instance. So if I need to share that EBS volume with other EC2 instances, the data in the EBS volume with the other EC2 instance, I will not be able to do that. So the file system, when we create a file system, it can be mounted with various different instances in different availability zone of that particular region also. So let's say I put some data in the elastic file system, or I put some important files or license files, some softwares in the file system. That can be picked and accessed by instances running in different availability zones. What we need to do, we just have to mount those instances with the EFS. So with the help of an EFS, we can create and configure shared file systems simply and quickly for AWS compute services. No provisioning, deploying, patching or maintenance is required. We can eliminate the capacity planning with fully elastic storage and performance. Only pay for the storage you use and reduce costs up to 90% by automatically moving infrequently accessed files. It is securely and reliably access your files with a fully managed file system designed for high availability, which is close to 11 nines. So it is a fully managed service by the AWS. The high availability, redundancy, elasticity, all will be managed by the AWS cloud. So what is an EFS? Let's look into from this slide perspective. Amazon EFS is a simple serverless, elastic, set and forget file system that automatically grows and shrinks as you add and remove files with no need for management or provisioning. So here you can see this is an elastic file system, and this can be mounted with multiple EC2 instances in different availability zones. All these EC2 instances can have the access of the files that are stored in the EFS, and then they can use it accordingly. Not only with the EC2, you can use EFS with Lambda also, with ECS, Elastic Container Service as well, with other AWS services. Even you can use the EFS with your on-prem servers as well. So how it works? If you look into the Elastic File System diagram here, the flow chart, the EFS, you create your file system using the EC2 launch instance wizard, EFS console, CLI or API, and this EFS can be mounted with Lambda, can be accessed by container services, Kubernetes services, Fargate, which is a serverless service, and also from the EC2 instances. Apart from that, you can mount it with the on-prem servers as well. And what you can do, you can test and optimize, you can move the data, you can share and further protect your file data as well. There can be a lot of use cases. It can be used in the DevOps, it can be used in modernizing the application development, where let's say if your servers require a license updates or patch upgrades, all those patches and licenses can be uploaded on the EFS. Enhanced content management system, so you can put the content in the EFS, can be accessed by the applications running on the EC2 instance, and accelerate the data science kind of an environment. So likewise, you can read through some case studies, and that would give you more idea about the EFS usage. Then the next service that we should be knowing is Amazon Web Application Firewall. This is the symbol representation of a web application firewall. WAF is additional service that you can use in your solutions, and it protects your web application from common exploits. It's just like a firewall. What does the firewall do? It prevents any malicious traffic towards your AWS resources. So it saves time with managed rules, so you can spend more time building applications, more easily monitor, block or rate, limit common and pervasive bots, improve web traffic visibility with granular control over how metrics are emitted. So let's say you are running a website and there is a lot of traffic that comes from the bots across the globe and you want to prevent them. So WAF is a good service to implement, and that helps you to easily monitor, block or rate limit common and pervasive bots as well. With the WAF, you can easily save time with managing your inbound and outbound rules as well. And with the WAF, it improves the web traffic visibility, which is not possible, or which is not, you do not have that much visibility when you use the security groups with the instances. However, security groups are also kind of a firewall, but web application firewall is an additional firewall that you can implement. So how it works? AWS WAF helps you protect against common web exploits and bots that can affect availability, compromise your security of the resources, or consume excessive resources also. What you need to do? In front of your AWS services, you just have to implement the WAF. So you can implement the WAF on the cloud front also, with the application load balancer also, with the Amazon API gateway as well, with AWS AppSync as well. And this WAF protect your web application from common web exploits. So you must be wondering that we have security groups for this kind of a task also, but the security groups are only used for some of the AWS services, like for EC2 instances, for RDS, but not for CloudFront, not for load balancer. So if you want to protect these services also, you need to have the WAF. And what you can do, you can have a firewall manager also that can manage multiple WAF deployments from a single place. What you need to do, you can create a policy, build your own rules in the WAF, block and filter, monitor from the CloudWatch how the traffic is moving towards your resources. And some of the use cases you can look into, it helps you to filter web traffic, prevent account takeover frauds, administer AWS WAF with the APIs. You can create and maintain rules automatically and incorporate them into the development and design process. So you can actually, WAF can be managed from external APIs as well. You can create the rules directly from the external APIs that will be implemented on the WAF. Now coming to the Elastic Container Service, which is an ECS. So this is a symbol representation of an ECS is. What exactly the Amazon Elastic Container Service is? And to understand better about the ECS, we should also know about the concept of Docker and containers. Amazon Elastic Container Service is a fully managed container orchestration service that helps you easily deploy, manage and scale containerized applications. As a fully managed service, Amazon ECS comes with AWS configuration and operational best practices built in. It's integrated with both AWS and third-party tools such as Elastic Container Registry and Docker as well. So it is a container orchestration service where you can have multiple containers orchestrated on the ECS or running on the ECS. And this is also a serverless kind of an environment, so you don't have to create a server for that. So mostly in the microservices architectures, if you have to build them, ECS or the Elastic Container Service would be a useful thing. Now before understanding in detail about the Elastic Container Service, we need to understand the concept of a Docker and containers, because the Docker's concept is widely used with the ECS. Till now, we have been working on the virtual machines, EC2 instances. And what happens with the EC2 instances? In the backend or in the data center of an AWS, there is a server, and on that server, the AWS is running a hypervisor, which is a virtualized environment that virtualizes the servers. And with the help of a hypervisor, we can build the instances, which are called as the virtual machines. Now, on each and every virtual machine, we require a guest operating system, and on that guest operating system, we need to host an application. This guest operating system could be anything. It could be a Linux operating system or a Windows operating system. So you can observe here that each and every virtual machine has its own app. Contrary to the infrastructure with respect to the virtual machine, if you look into containerized application environment or the Docker and containers, the infrastructure is same. There also the host operating system is. So instead of an hypervisor, it is replaced with the host operating system. So on the server or on the infrastructure, let's say a Windows host operating system or a Linux host operating system will be installed. But now the virtualization of an operating system is done. That is called as a Docker. So here, the infrastructure was virtualized with the help of a hypervisor. Now, in the case of containerized application, the infrastructure, the host operating system is running, and that is virtualized with the help of a Docker. And on the Docker, multiple different applications are running. And these applications, app A, app B, app C, are called as a containerized application. They are running in the form of a container. So what are the benefit of running the containerized application? The benefit is, like, if I need to modify any particular application, I don't have to stop the entire server or the virtual machine. Whereas in this case, if I need to modify anything, I need to stop the virtual machine. I don't have to do that in the containerized application. And all these containerized applications can be initiated in the cluster form. So complex architectures like e-commerce platforms, they are mostly deployed with the help of these containerized applications. And where exactly these containerized applications can be hosted? On the AWS Elastic Container Service. So Amazon ECS has certain components. There are three layers. One is capacity option, second is controller, and third is how you do the provisioning of the containerized applications over the ECS cluster. So that's why we say there are three layers in the Amazon ECS. One is the capacity, the infrastructure where your container runs. Let's say you create a container in the EC2 instance. You create a container image in the EC2 instance. That is possible. You can create a container image in the AWS Fargate service as well. Even you can create a container image in the on-prem servers as well. Then the controller. Controller deploy and manage your application that run on the containers. It is a kind of an ECS scheduler. And then comes the provisioning, the tools that you use to deploy all these containerized applications on the ECS. It could be an AWS CLI also you can use. You can use the management console also, and then you can use some software development kits, SDKs as well as CDKs, cloud developer kits also you can use. Along with that, you can use some third-party pilot tools as well. So these are the three layers that are required when you work on the Elastic Container Service. Now coming to the next part or the next service of an AWS is the Amazon API Gateway. And this is a symbol representation of an Amazon API Gateway. API stands for Application Programming Interface. And with the help of an API, you can connect with various different AWS services in the application layer. There are so many API tools, open source API tools that are available. There is Swagger, Postman. All these are the third-party open source tools. You can build your APIs also. You can create a mobile application, web applications as well. So Amazon API Gateway is an interface. It's an AWS service for creating, publishing, maintaining, monitoring and securing REST, HTTP and the WebSocket APIs at any scale. You can build the APIs from the API Gateway also. You can connect the third-party APIs with the API Gateway as well. So when you connect your third-party APIs which are outside AWS, let's say if you create your own API and you want to connect it with the DynamoDB, for example. So API Gateway will be an interface for that. Okay. So API developers can create APIs that access AWS or other web services as well as data stored in the AWS cloud. So what is an architecture of an API Gateway? Here you can see this is an Amazon API Gateway. It can be connected with web and mobile application, with Internet of Things devices, with some users that are users and streaming dashboards. It can be connected with the private application using VPC and on-prem environment also. The API Gateway is used to create, publish, maintain and monitor the secure APIs, connectivity as well as APIs also you can build it. And then from the API Gateway you can connect with various AWS services like EC2, Lambda, you can connect with Kinesis, DynamoDB and many more. So API Gateway acts as a front door for application to access data, business logic or functionality from your backend services such as workloads running on the cloud, code runnings on the Lambda, any web application or a real-time communication application with the Kinesis pipeline as well. Thank you for watching this video.